2 moles of an oxidizing agent, XO4 minus, in the presence of excess acid, oxidize this number of moles of nitrogen dioxide at room temperature and pressure to NO3 minus. Okay, what is the number of moles of electrons accepted by 1 mole of XO4 minus? All right, so normally this type of questions, you always have to try to find out the mole ratio first. All right, so let's see how you do it. All right, what's the number of moles of NO2? All right, is to the number of moles of XO4 minus. Okay, and I know the half equation for, I have to write the half equation for NO2 to NO3 minus. So NO2 becomes NO3 minus. So this is being oxidized. All right, so you have to calculate the oxidation state of nitrogen, because the oxidation state of nitrogen changes from +5. All right, from, sorry, it's not from +5, it's from +4. Okay, let me change it slightly. Okay, it's NO2. Okay, so it's actually from +4, okay, to +5 over here. So it was actually oxidized. So the number of electrons have to put +E over here. Okay, so +4 to +5, it lost 1 electron. Okay, so let's calculate the number of moles of NO2 and XO4 minus. So this is all done at room temperature and pressure. So it'll be 96 divided by 24, right? Which actually is equals to 4, right? What's the number of moles of XO4 minus? So 2 moles of XO4 minus, as mentioned over here. All right, so the very simplest ratio is 2:1. Okay, so 2:1. So with that, okay, so you can see that for every 2 moles of NO2, 2 moles of NO2 will actually lose 2 moles of electrons. So you lose 2 moles electrons, and these 2 moles electrons will be accepted by 1 mole of XO4 minus. So that's the answer. Where the number of moles of electrons accepted by 1 mole of XO4 minus, so the answer is actually 2. Okay, so that's why it's B.